Okay, the final part is, all right, how can I apply, in the same way when we first did our transformations, we worked out, okay, how is the point affected? Now we want to look at how is the equation affected, all right? So find the equation image under the graph, under the matrix transformation defined as 2, 0, 0, -3, and describe the sequence of transformations, all right? So we might be able to describe the sequence of transformations here. So what we do is this is why we sort of did all this x dash y dash stuff at the start. X dash y dash is equal to, okay, the transformation 2, 0, 0, -3, which is then applied to just the point xy. Okay, so if I do my matrix multiplication now, this implies then that x dash y dash is equal to 2 times x plus 0 times y, which is 2x, and 0 times x plus 3 times y, which is 3y. So if I just equate the elements, that means that x dashed is equal to 2x, y dashed is equal to 3y. Now, hopefully from here, that looks familiar to us. That's very similar to what we were doing, okay, in terms of our transformations. So if I rearrange this, I know that the x value is equal to x dashed on 2, the y value is equal to y dashed on 3. Okay, so if I now apply that to the function I've been given, now in this case the function is y equals 1 on x. So since y equals 1 on x, I can say the y value, y dashed on 3, is equal to 1 over the x value, which is x dashed on 2. So now that I've got the dashes, I've got my new equation. So this is the new equation, so I'll leave dash off. Y on 3 is equal to, divide by a fraction, flip it upside down and multiply, 2 on x. So multiply the 3 across. So there's my new equation. All right. That's my new equation. What were the transformations that took place? Well, I can get that from here. X dash y dash is equal to 2x 3y. So what happens if I multiply the x value by 2? It moves it from the y-axis, doesn't it? So it's a dilate from y-axis by factor of 2. And if I multiply the y value by 3, well, it's stretching it up from the x-axis. Dilate from x-axis by factor of 3. All right. So once we've got our transformation matrix here, we apply it to the xy point to come up with a set of equations or a relationship between the new x value and the old x value, new y value, old y value. And then we can go back to the same process that we had been using previously. All right. Last one, we can see here that we've got a little bit more to our transformation. All right, we want to apply this series of transformations to that particular equation. So let's have a look at how we can set this up. We've got my new x value and my new y value are going to be equal to the t term, 0, -3, 2, 0, times in brackets the old x and y plus b, which is 1 and 2. Yeah, so it's the order of operations. The alternative way this could have been written, it could have been written as tx plus b, in which case we'd have 0, -3, 2, 0 times the xy plus the 1 and the 2. Yeah. So in this case, we've got the 1 and the 2 inside the bracket and then the transformation being applied. So I'm going to have x dash y dash will be equal to 0, negative 3, 2, 0 times, when we add matrices of the same order, we just add the corresponding values. So I get x plus 1 and y plus 2. So let's just stop there for a minute and think about what that means. X value plus 1. If I add 1 to the x value, I shift it to the right 1 unit. The y value plus 2, if I add 2 to the y value, I move it up 2 units. So this term here, that's my vertical and horizontal translations. Okay, the top value adding to the x moves it horizontal. The second value adding to the y moves it vertically. So now let's expand this, multiply this matrix out. I get x dashed y dashed is equal to 0 times x plus 1 plus negative 3 times y plus 2 and 2 times x plus 1 plus 0 times something. Now this one's a little bit, notice how the values are in the opposite corner, which means my x and y values have swapped. So it's a little bit of an inverse kind of thing, all right? But that's okay. So what does that mean? It means now that x dashed is equal to negative 3y minus 6. Y dashed is equal to 2x plus 2. And we're going to do exactly the same thing now. I've got an equation I've got to apply it to. But first I've got to work out what the y term is and what the x term is. So if I rearrange these, I'm going to get x plus 6 over negative 3 is equal to y. And I'm going to have y, we'll make it a dash, y dashed minus 2 over 2 is equal to x. Yeah? So now I can substitute those values in for x and y. The y expression here in green is equal to x dashed plus 6 over negative 3 equal to 2 times, in red, the x expression, y dashed minus 2 over 2 plus 5. Yeah, so I've substituted in the y value, substituted in the x value. This now gives me the new equation. Well, what's the easiest way? Well, let's maybe just keep that as x dash plus 6 over negative 3 equals, multiply this bracket out so they cancel. I get y dashed minus 2 plus 5. So x dash plus 6, I'm going to bring negative 3 across. Y, negative 2 plus 5 is positive 3. So I get x plus 6 equals negative 3y minus 9. So really we tend to get y equals, don't we? So if I take the 9 over, I'll get x plus 15 is equal to negative 3y. Divide everything by negative 3. Y is equal to x plus 15 over negative 3, which is my answer. I might tidy it up. I get y equals negative x on 3 minus 5. So that's my new equation under that particular transformation. All right, there's a little bit in that. Stop, think through it, practice.